It gives me immense pleasure to see you all participate in the Tech Talk program. Pune Club is organizing wonderful Tech Talk programs every month on different subjects. Due to the pandemic, this program started and it is going on very well. I have to congratulate our Vilas ji and all the committee members of Pune Club for conducting this Tech Talk quite successfully every month. And I think not only the local hams, but also the other hams all over India and over the all parts of the world, I think they are able to see this presentation, and also the recording is made available so that even people can watch that later. So, friends, today I am going to talk about the electronic load. Already our Vilas ji has given a brief introduction about this gadget. Now, when we want to communicate either in HF or VHF or UHF, we require three things. One is the antenna to receive the signal and also transmit the rig for the particular frequency, and the third one is the power supply. Power supply, we are not able to use the AC power supply directly. We convert the AC supply into a DC supply, 13.8 volts, using different power supplies. So most of the rigs operate on 13.8, and some linears operate on 24 volts, 48 volts, like that. Now, we have two choices. One is a linear power supply, which has got regular transformer, rectifier unit, and the regulation circuit and all that with protections. The other one is SMPS, switch mode power supply. Both these power supplies are extensively used by our hams for communication. Now, when we have a power supply unit, what are all the tests to be performed? That is the task before us. Once we assemble or when we buy also, the power supply has to meet certain criteria. The first and the foremost one is the output voltage. The output voltage, we should get the desired voltage. 13.8 means we have to get 13.8. And in many of the power supplies, SMPS as well as linear, there is a provision to adjust the voltage as we require. So this can be set. The next one is the stability of the output voltage. If we keep it at 13.8 and once we start using, it should not fluctuate. The fluctuation may be due to the AC power supply fluctuation or other deficiency of the control circuit. So the stability of the output voltage is very, very important. So it should be maintained at a constant voltage, say 13.8 volts. The next one is ripple content. When we talk about a DC, there should not be any ripple. The ripple should be very, very minimal so that the DC power will be fully utilized by the rig. I will skip for the time being the current delivering capability. I will take it up a little later. Next one is the high voltage trip protection. Any power supply should have a high voltage trip protection. Suppose we are operating at 13.8 volts and suddenly if the voltage goes beyond 15 volts, it can damage the rig. So there should be a high voltage trip incorporated in the circuit, protection circuit, so that in case of any high voltage, immediately the power supply should trip. The other one is the low voltage trip. Again, when the voltage goes down, it will try to draw more current, and there should be a low voltage trip as well. Over current trip. This is also very important. Suppose we are having a 13.8 volts power supply with some 25 amps. Then if the current drawn is very high, there should be a trip protection. That is over current trip. Then heat generation. Whenever we are converting using this, there will be some heat generation. This heat generation should be under control. So there should be adequate ventilation, adequate fan to cool the heat sink and other electronic components. Now, current delivering capacity. This is the most important thing. So checking the current delivering capacity is also known as the load test. That means if a power supply is rated for 25 amps, when we draw 25 amps, it should be able to maintain the output voltage at that rated current. So this is very, very important. Now, how to conduct the load test? What are the various methods available? I was homebrewing a lot of power supply units, mainly the very popular Marchut power supply and other power supply for my use and also for some of my friends. So all other things, parameters, as I told in the previous slide, that can be checked with the multimeter and oscilloscope and all. But when it comes to the load test, it was a problem. So I asked my other friends how they are doing it in the initial stages. Somebody said they are using high wattage bulbs, like automobile bulbs, which are rated for 12 volts. They were using it, number of bulbs, and they were increasing the load current. This was one of the methods followed. Then somebody said they are using nichrome wire. So nichrome wires are available, and it can be also connected as a load, and the current can be increased. That is one method. The other method is heating elements. For example, in diesel engine, we have a heater. Whenever the diesel engine is to start, cold start, they use this heater for some time so that the diesel engine will start quickly. So these elements are available. So one can connect a number of such elements in parallel and increase the load. The other method available to us is the electronic load. That is what I am going to explain today. So in my talk, I'll be covering the construction, circuit, operation, what components are required, and explain the circuit, and also show my own homebrewed electronic load. And finally, there will be a demo. So this is the, in nutshell, about the today's presentation. Now, I said some of the methods by which we can load test a power supply. What are the disadvantages? If you are using number of bulbs, it emits brilliant light. So what happens, at a particular stage, the brilliance will be more and more, and also it gives intense heat. When the bulbs are glowing, it is intense heat. If one touches the bulb, then there will be a serious burn. So it can cause burn. Similarly, when we are using nichrome wire, or when we are using the heaters, that will also become red hot. It can also cause burns, and it will also emit intense heat. This brilliant light also can affect the vision, and fire hazard is there. Suppose we are keeping it, and by accident, if it comes in contact with some combustible material, it can also lead to fire hazard. So I feel these methods are little unsafe. And another major disadvantage is we can increase the current only in steps. We cannot have a smooth increase of current, say 2 amperes, 3 amperes, 4 amperes, or in between 2.5, 3.5, nothing can be done. Once you connect a bulb, it will take a particular current. Then you connect another bulb, it will take more current. It will be only in a step change. It cannot be a smooth change. So that is one another disadvantage in using these methods. Now, advantages of electronic load. Compared to the other methods, what are the advantages when we use an electronic load? Here, there is no external heating, because the heat generated is in the heat sink, which is well protected within the cabinet. So there is no chance of heating and affecting. The other one is no brilliant light, nothing, no light at all. The other advantage is simple and smooth adjustment. We can, just by rotating a knob, a control, we can smoothly increase the current and decrease the current. So I feel because of these advantages, it is very, very safe, not only safe, but also very easy for operation. And another advantage is here we can visually see the parameters. If you are using a heater and other things, then we have to put external voltmeter, then current meter, and see everything. But here we can have built-in meters. which can visually show us the various parameters. So these are all the main advantages of electronic load. There are some disadvantages as well, but the disadvantages are very less. One is the cost. Compared to the nichrome wire or the automobile bulb or heater, the cost of constructing electronic load will be more, but it is not going to be very, very expensive. For a home brewer, it will be at an affordable thing, but we are deriving a lot of advantages of that. Complexity. Complexity in the sense we have to build an electronic circuit and also put it in a cabinet and provide all the controls and homebrew the gadget. If we are using only a bulb, even a wire can be connected and it will be very simple. So there is little amount of complexity. Now, this is my homebrewed electronic load. I have put it in a cabinet, and this cabinet measures about 10 inches width and about 6 inches height and about 8-9 inches depth. So this is the cabinet. I have two indicators, digital indicators. One is for voltage. This is for the voltage, and this is for the current. In the front panel, I am having a switch, on-off switch for the power supply. Each requires a power supply. I am using a AC power supply 230 volts, and I am deriving 12 volts DC internally. So this switches on and off the power supply inside from 230 volts to convert to 12 volts. This is the knob for increasing or decreasing the current. So by rotating clockwise, the current drawn can be adjusted. This is the fuse protection, which is in series with this. In case of any high current, this fuse will blow and it will protect the gadget. There are two terminals marked red and black. These two are for connecting the power supply positive and negative. Positive goes to red and negative goes to the black. So directly the power supply, which is to be tested, that output will be connected to these two terminals. Now, this shows the internal arrangement of the electronic load. Now, you can see in the front, these two digital indicators are there. Two digital indicators for the current and the voltage. Voltage, of course, it is very simple. For current, I am using a sensor. That sensor gives a millivolts output that is fed to the TPM, digital panel meter. So the current is drawn, current is measured using this device. And this is a small SMPS. This small SMPS receives 230 volts and it delivers 12 volts. The red and black wire gives 12 volts. And this is the control board. This is the control board, which has got the IC and other resistors, capacitors, and all that. Now, in the rear side, there is a big heat sink. In the heat sink, you can find 4 IRF P150 are installed. There are 4 numbers, and these are the high voltage resistors. I will explain the function of this in the subsequent slides. Here on the right side, there is a high-speed fan. This high-speed fan is also getting 12 volts. It is driven on 12 volts. So once we switch on the unit, the high-speed fan will run and it will continuously cool the devices mounted on the heatsink and as well as the heatsink. So I have put a insulation sheet so that there should not be any short circuiting of the control circuit to the other elements. So this is the internal arrangement. Now, this shows the other view of the internal construction. Now you are able to see the black heatsink. There is a large heatsink and all the IRF mounted distributedly are seen, and also we can see the high voltage resistor. So nowadays this IRF it was extensively used in UPS circuits. But now this IRF is very, very commonly used even in RF amplifiers. Many of the IRF like P150, P250 are extensively used in even HF linears. I have constructed a high voltage linear using P250. So in this circuit board PCB, homebrewed PCB, you can see the voltage 12 volts coming and other rectifying regulators, because this 12 volts has to be reduced to 5 volts for the control circuit. And this is the IC and the other resistors are there. So this is the general arrangement inside. If you have provision to feed 12 volts directly also, this SMPS can be avoided. For versatile operation, I have put a SMPS inside and I'm using this with the 230 volts. Now, this slide shows in a power on condition. Now you can see the voltmeter and the current meter, both are showing 00 value. Now this is a side view. In this side view, you can see the fan and the grill. High-speed fan is connected internally. Okay, this is the rear side view of the electronic load. I've used a removable type of power socket so that the power cord can be disconnected and connected as and when required. So this is only for convenience. And it operates on 230 volts. Now we have come to the slide which shows the circuit. As I said, I am deriving 12 volts from the SMPS, small SMPS, because the current requirement is very, very low. So I'm using a small SMPS which gives positive 12 volts, and this is the ground. I'm using a regulator 7805 to bring the voltage to 5 volts. The smoothing capacitor, decoupling capacitors are there. And this 5 volts is fed across a potential divider. The potential divider comprises of a 10K resistor and a 1K variable resistor. And also in parallel, there is a 100 ohms resistor for smooth variation. So this is nothing but a potential divider. Now, if you see, these are the 4 MOSFETs. All are these are the 4 MOSFETs. IRF P150, and this is LM724. It has got 4 sections. 4 sections. I have utilized all the 4 sections of one IC, LM724, which acts as the voltage to current converter. Now, in the circuit, the gate of the IRF P150, all the things are connected to the output of the LM240. Let us consider one section, and the same is applicable for the other 3 sections as well, because they are similar. Only to increase the total current, I have used 4 different IRF P150. So all are same only. So now here, the voltage from this potential divider is fed to the pin number 4 of the IC724. And the output through a 100 ohms is connected to the gate. All of us know very well, in a MOSFET, if we increase the bias of the gate, the current increases. From source to drain, the current increases. So here, there is a feedback. There is a 0.1 high voltage capacitor, and between the source and the ground, there is a high voltage resistor of 0.1 ohm, and that is the feedback is taken, given to again the pin number 2 of the LM724. Now, if you see, the drain is connected to the positive, and the source through the high voltage resistor is connected to the negative. So the same is applicable to all the 4 sections. So same only. So each section will be sharing the total load. Suppose, so it will be 25%, 25% like that. All 4 sections put together, it will be 100%. Now what happens when we increase this voltage using the potentiometer loading adjustment, then the voltage increases. Once the voltage in the pin number 2 increases, then immediately the output increases. Once the output increases, the IRF starts drawing more current. When the current is more, the voltage drop across this high voltage resistor 0.1 ohms also increases, and this is given as a feedback. So immediately the feedback takes care to stabilize the current. So whatever input is given, and the input and the voltage derived will be same, and then the current drawn will reach a steady state. So this is the arrangement and the circuit and operation. I hope it is clear. So as I said, one section I have explained, the same thing holds good for all the 4 sections. Now, what are the major components required in this circuit? One is IRF P150. We need 4 numbers. I have actually designed it for about 20 amps. So 20 means about 5 amps easily one IRF P150 can handle. So 4 numbers of IRF P150, then 1 number of regulator to reduce the voltage from 12 volts to 5 volts. And this is 12 volts, 1 ampere power supply used. But if you have directly 12 volts, that can be also used. And this small SMPS can be avoided. Resistors 1 lot and 1 K pot. This is required for increasing, decreasing the current. LM324 1 number, heat sink, large heat sink 1 number. Here one has to distribute the mounting of the MOSFET in a different location, so that it is not advisable to put them side by side. Then what happens? All the devices will get heated up, especially at higher current, and the heat sink in that particular area will get heated up. So it is better to distribute it and do the wiring accordingly. We require a cooling fan, of course, and 1 lot of capacitors and 1 cabinet. So these are all the main items required. Now, how to scale up is the next question. How to scale up means how to increase the performance or the load current or voltage handling capacity of the load, electronic load. Now, one method is to increase more number of MOSFETs. Instead of 4, we can use 6 numbers, 8 numbers. So each MOSFET will share the current, so the total current handling capacity can be increased. Then the other option available to us is to use different devices with higher rating. See, there are MOSFETs available now which can handle higher voltage and higher current. So in the place of IRF P150, we can use P250. Suppose we are using more than 4 numbers of IRF, either 150 or 250. The IC also we may have to add 1 more IC to feed the voltage to the gate. So these are the options available to us to increase the total handling capacity or scale up. Now, before almost we have come to the end of the presentation. Before concluding, I wanted to just to show a demo. Here in this demo, I have used my own homebrewed Marchwood power supply and also the electronic load. During the demo, you can see there will be a slight difference in the voltage readings of the power supply unit and the electronic load to the extent of about 0.2, but I have not adjusted. Still, I took the video, so don't mind about the small variation. But functionally, you can see how to operate and how simple it is to test the loading of a power supply. Now I will start the video presentation. I want to make a demo of how to test a power supply using the electronic load. So this is a homebrewed Marchwood power supply. capable of delivering 13.8 volts and 30 amperes. And this is the electronic load. Both units requires 230 volts power supply. Both are connected to the extension board, 230 volts. The positive and negative of the power supply unit are connected to the positive and negative of the electronic load. I have kept very short wire to avoid drop in the wire. Now I am going to switch on both the units and test. This is actually the rotary control for increasing the current from the power supply. As a precautionary thing, I am ensuring it is kept at the lowest position so that there will not be any current drive. Now let me switch on the power supply. This is the push to start switch. Now the power supply is delivering 13.7 volts. Now let me switch on the electronic load. You will hear a noise because of the high-speed fan provided in the electronic load. This fan is cooling the heat sink inside. Now I am going to increase the current by slowly rotating the potentiometer. Now let us see how the power supply is able to take care of the load. I am increasing. Now it is drawing about 2.9 ampere, 4.6 ampere, now about 11 ampere, now 17 ampere, going up to 24 ampere. Still the output voltage is same. So I am reducing the current back to 0. So we could see the power supply is capable of delivering 13.7 volts without any drop, even at trial of a higher current more than 20 amperes. So this shows how the electronic load is used. A very simple way to test power supply loading. I want to make a demo. Okay, friends, we have come to the end of the presentation. I hope all of you enjoyed, and I like to thank all of you. I think there are about 18 members who are participating in this tech talk for your patient listening. And if there are any questions, I am prepared to answer. Normally, many people use a long wire in the positive and negative from the power supply to the rig. It is not really advisable to. It is better to always keep this wire of sufficient rating, 4 square mm and above, and it should be as short as possible. Otherwise, even though the power supply is delivering 13.8 volts, there will be a drop in the power supply cable. So it is always better to keep it very short as required. So this is one suggestion from me. I hope the presentation covered all aspects. If there are any questions, I'll be too happy to answer.
Thank you, Tagu, for this wonderful technical presentation. Really, it has given a good insight to all the hams. I am thankful to you. Let's have the question and answer session. Request all the participants to identify themselves, tell the name and location, and then let's go and then fire the question. Over to the audience.
मेहता बोलतोय, बोलू का रबडे साहेब 2 मिनिटं? माझा आवाज येतोय का?
Yes, sir. Go right ahead, sir.
हाँ, मी प्रोफेसर मेहता speaking. Am I audible, sir? रबडे सर?
अरे एक मिनिट हमारे
माझ्याकडे ते अनम्यूटचं ऑप्शन दिसत नाही ते.
एक मिनिट wait for a minute because I am muted. एक मिनिट. अरे यार एक मिनिट.
हो, no problem.
एक मिनिट. Go ahead, but in Marathi, English. एक मिनिट. जरा तिकडे आणि का मध्ये बसली का तू तिथे? मला काही करता येत नाही ग.
Lastly, we are copying everybody, Mehta Sahib and you also. So no problem. Continue.
Right, sir.
Mehta ji, you please speak in English. Please fire your question in English.
I think there's some problem at his end. So can I ask a question, Vilasji? This is VU2 Sierra Papa Foxtrot Bhatnagar.
Yeah, please go ahead.
First, you have to shut down one of your audio, Vilasji. There is a lot of echo.
Yeah, I'm hired. Go ahead.
Now, this is Professor Mehta speaking. Am I audible, sir?
Yes, please. Yes, please, Mr. Mehta.
Now, there is no doubt about your presentation because it is all nicely done. So it's quite convenient and useful, everything. I have only one or two suggestions. I have shared one image to Rabde sir, but I don't know how to share it here. So it is a normally available item in a market, and it is a stainless steel made stepped resistor, that rather punched resistor. So it is very rigid in operation, and it is available. I have seen 0.001 ohms to 3.5 ohms and about 500 watt wattage. And it is very rigid. That means you can handle it very roughly. And you can connect such in parallel series to achieve whatever you want. Only that high current switching and parallel connection is there, but there is no 230 volt power supply requirement. There is no separate SMPS, etc. It is a simple resistor available market and used extensively as a brake resistor, as a many places. So this was only a suggestion. My image I have shared to Rabde sir, but I don't know how to share it here. So Rabde sir can transmit this image, but it is available product in market. And second thing, that earlier when we had a load problem, in emergency situation, not a regular, but it is not very convenient, but it is very useful. I have used simply water load by adding a required amount of salt in it, and it works very well for many situations where you don't have access to any other electrical items. Just a water. Of course, there are problems, but when the water starts boiling, etc., you have to add water, you have to add salt and adjust. But it is very convenient before you get some proper official professional load. So these are the two suggestions I wanted to make.
Okay, Mehtaji, thank you. Yeah, I told you that the nichrome wires are available, even diesel engine heaters are available. But when you are using such, this is also what resistor you mean, it is also a load, of course, agreed, but you have to connect it, and you should have a device to, parallel many of these resistors by a switch arrangement or some shorting arrangement, then only the current can increase.
Yes, no, there is no doubt about the inconvenience.
Excuse me, sir. Let me finish it, sir. 1 second.
Okay.
So you again you require a switching arrangement which has to handle the higher current.
Yes, high current switches.
Then the next one you said about the water. Actually, I don't even take a cup of tea inside my shack. So there is a possibility of some spillage when we are handling this electronic stuff.
Yes.
Water again handling. Yes, there are so many ways like that, but it may lead to some spillage of water and other things. There are, of course, I agree, there are methods, but here you would have seen a small gadget which is which can be used very conveniently, and also you can give very smooth increasing or decreasing the current. It will not be a step change. That is my reply, sir.
Yes, sir. Thank you very much. No, I have no doubt about your convenience. I just told what I have used earlier and found sometimes inconvenient in emergency situations only, not as a regular these things.
Yes. If one cannot homebrew, yeah, they have to find out their own method. Thanks for sharing your.
Okay. Thank you very much.
Let us go for the next question.
Yeah. This is VU2 Sierra Papa Foxtrot. Can I ask a question, Vilasji?
Yeah, yes, please. Bhatnagarji, please go ahead.
Yeah.
Tyagarajan, it was wonderful presentation. Actually, I wanted to see it for a long time. because best thing is you can continuously adjust the current, and that is really a very useful feature. Just wanted to, I was just curious to know if you have tried it as a dummy load for RF, Tyaguji, or
Yeah, is it that your question?
did you try it as a dummy load for our RF the testing over?
Okay. See, dummy load and electronic load are both different for used for different applications. Dummy load is only a 50 ohms load which can handle RF power at a higher wattage. So there are different dummy loads available. So even we can homebrew for 40 watts using 2 watts resistors, number of resistors in parallel, or we can have even nowadays a small chip is available which can handle about 250 watts, or we can have something like that oil immersed which can handle up to 1000 watts and all. But that is all 50 ohms resistor for testing the output of the RF. So here this is different. This is testing the capacity of the power supply. So both are functionally little different. The load is the only common word, I think. Is it okay with you, sir, Bhatnagarji?
Yes, perfectly fine. No, I'm just curious to know if anybody has tried. Thank you very much. It was fantastic presentation, Tyaguji. I'll contact you over WhatsApp soon. Over. Thank you.
Thank you, sir.
Thank you, Bhandarajarji. Let's go for the next question. Any more questions, or the presentation is so clear that there is no question in your mind? Okay, Tyagu, let's check up whether there are any questions in the chat box.
Sure.
No, only nice presentation. Yeah, I don't think there is any. So I think we have come to an end. It was a lovely and crisp presentation. Normally we allow 40 minutes and rest of the time for question and answer, but you did it in 30 minutes and very clear-cut message about the electronic load. And I also appreciate the question from Bhatnagarji, whether the same electronic load can be used as a RF load. And I think Tyagu has rightly answered it, because it is not meant for this RF amplifiers. We also clearly clarified in the beginning that it is used for battery testing as well as power supply testing. It may be SMPS or linear power supply. So thanks a lot, Tyagu, and we appreciate all the participants. In spite of Sunday morning, 16 people participated. Of course, the recording will reach to more than 1,000. So I declare this presentation complete, and we will go QRT, saying 70 thieves to everybody. And Tyagu, I want to say something. Please go ahead.
Yeah, I see many of my friends whom I'm contacting quite regularly. We have Ham from Melbourne, VK3IR, Old Man Subramaniam from Melbourne. I'm able to see a very senior homebrewer, Mr. Vaidyanathan Nath from Tiruchur, and also Tango Whiskey Zulu Alex. So there are so many friends. These friends, regularly I contact them, and there are other friends as well. I need to thank you, Vilasji, for giving me this opportunity to present. In the months to come, again, probably I will come up with some other gadget, and I'll be too happy to share my work. After all, knowledge is for sharing. I also like to congratulate once again you and your team, the Pune Ham Club, for the excellent participation, excellent organization, especially not only this Tech Talk. There are so many monthly programs you are running. Wonderful, wonderful, and kindly keep it up. And my appreciation on behalf of all the participants, Vilasji. I thank everyone for your patient listening. Thank you. Good day. Good morning.
Thank you, Tyagu, for kind words. But we have not given the opportunity. Rather, you have given us the opportunity for this technical presentation, and we want many more. I will keep on troubling you that we want your presentation on this month, that month. Please honor our request, because your presentations are always interesting, straightforward, and really motivating to the newcomers. And that is what our intention is, that more and more should come on the band, and there should be more and more homebrewers. So friends, I declare today's presentation is over, and definitely we will meet next month for another interesting presentation. Thanks a lot. 73 is 88, and good morning.
Namaskar.
Namaskar. Yeah. Chalo, have a nice day.
Happy Sunday to everybody.